Welcome to the Surgical Theatre. I'm your host, your resident strategist, and today we are undertaking a high-stakes dissection of one of the most notoriously challenging areas in the Cambridge IGCSE and Additional Mathematics syllabus. We are talking about subject code 0606, trigonometric graphs. Specifically, we're going to use precision instruments and steady hands to wrangle those terrifying equations with the a, b, and c variables. I want you to picture a timer ticking down on a real Cambridge mathematics past paper question. We are going to look at two hypothetical students taking this exam today. First, we have Alex. Alex overloads his answers with raw mathematical facts, writing down everything he knows about the unit circle, but completely lacks analysis. Then we have Sam. Sam rushes through the paper, completely missing the specific command word requirements, just desperately sketching curves without thinking. By the end of this explainer, you are going to learn how to avoid both of their fatal mistakes. We are going to decode exactly what examiners are looking for, transforming complex mathematical curves into a clear, structured sequence of guaranteed marks. Our structured playbook today will take you from the core principles straight through to the critical examiner warnings that cost students like Alex and Sam crucial marks. Section 1 is all about unlocking the conceptual mindset required for trig graphs. Then in Section 2, we're going to reveal the strategy, the core theoretical principles that underpin top-tier answers. From there, Section 3 gives you the transformation, a strict technical methodology framework you can apply to every single question, shifting from red pen marks to green check marks. Finally, in Section 4, we'll open up an interactive workshop based on critical examiner warnings sourced directly from Cambridge postmortems. We're going to build your ultimate mathematics success blueprint. To start, we have to ask a massive question. Why do so many candidates completely freeze when applying these specific graph concepts to unfamiliar contexts? It's a phenomenon Cambridge examiners see year after year. Let's look at Alex and Sam's flawed answers on a classic y equals a sine bx plus c problem. Alex perfectly memorized the standard sine wave, oscillating between 1 and -1. But the moment the examiner introduces an a variable for amplitude, a b variable that alters the period, and a c variable that shifts the entire graph vertically, Alex's foundational understanding just vanishes. He throws raw facts at the paper but doesn't actually analyze the transformation. Sam, on the other hand, sees the equation and just rushes to draw a generic squiggly line, completely missing that the command word was evaluate, not just sketch. Why does adding a few constants turn a straightforward curve into an absolute exam day nightmare for both of them? The Cambridge Principal Examiner reports highlight exactly where things go wrong, giving us the perfect roadmap to save your grade. And this quote brilliantly illustrates the root of the problem. Students confuse cause and effect. Answers are not specific to the context given. Let's dissect this with surgical accuracy. When a question in paper 0580 or 0606 asks you to model a real-world scenario, say the height of a tide over time using a cosine graph, students like Sam often just draw a generic curve. They fail to link the mathematical cause, like changing that c value, to the physical effect, like the actual minimum water level of the tide. Alex will write a paragraph defining what cosine is, which is not specific to the context at all. This disconnect is the absolute #1 barrier to scoring high marks. Let's move to our first section. Unlocking these graphs requires a major shift in your analytical mindset. We are moving into the strategy reveal. It is not about having a steady hand with a pencil. It is about surgical precision in your thinking before your pen even touches the exam paper. We have to break down the specific assessment objectives set out by Cambridge. Top-performing students don't just memorize the curves. They develop a connected understanding that adapts to any scenario the exam throws at them. The syllabus explicitly emphasizes this. Mastery isn't just knowing that a is a positive integer. Mastery is recognizing the mathematical machinery. To do this, top students use a framework we call PEAL. Point, evidence, explanation, link. For a trig graph, your point is stating the transformation, like the amplitude is increased. Your evidence is pulling the exact value of a from the given equation. Your explanation is detailing mathematically how it stretches the y-axis. And finally, the link is tying it back to the specific context of the question. If b is 2, the graph completes 2 full cycles in half the space. If you truly conceptualize that PEAL framework, it doesn't matter if the exam question is about pendulum swings or alternating electrical currents. Your connected understanding transfers seamlessly. So what are the core principles of a perfect answer? Let's move to Section 2 and transition from basic knowledge to the logical reasoning that Cambridge actually rewards. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to the operating table. We need to look at how we construct the architectural foundation of your responses. This comparison right here brilliantly illustrates what examiners truly want. They prioritize analytical depth and logical reasoning over a superficial breadth of knowledge. We see Sam doing exactly the opposite. Sam relies on superficial breadth, looks at the equation, punches a few numbers into a calculator in a complete panic, plots some random dots, and hastily sketches a wobbly line hoping for the best. Sam is just rushing to the final answer. But the examiner is looking for analytical depth. Did you calculate the maximum and minimum values logically? Did you identify the periods systematically? Did you decode the command word? It is the clear working and the structured reasoning that actually secures the marks, not just the final ink on the page. Your answers must rest on a theoretical architecture of precise definitions and causal relationships. Let's play a quick game. I want you to mentally spot which hypothetical answer follows the Peel framework we discussed. Is it Alex, who writes, sine waves go up and down between 1 and -1. The graph is shifted. Or is it a top-tier student who writes, the maximum value is 5, point, because the amplitude A is 3 and the vertical shift C is 2, evidence. This stretches the standard curve vertically and translates it upwards. Explanation, meaning the peak electrical current in this circuit reaches 5 amps. Link. Obviously, it's the second one. Referencing cross-topic collections like that achieves significantly higher marks. When you show the examiner you can integrate these graphs with other syllabus areas, you elevate your response from merely descriptive to highly analytical. Now, let's switch gears into Act 3, the transformation. We are moving away from abstract theory into the specific, procedural, technical methodology you need to execute in the exam hall. We are going to take Alex and Sam's flawed answers, apply a strict framework, and watch those red pen marks transform into green check marks right before our eyes. Every single time you face a trig graph question, you must follow this strict 5-part standardized processing sequence. This is your mathematics success blueprint. Imagine a 60-second timer going off. First, deconstruct the question. Identify the command word. Are you sketching, solving, or proving? Second, extract relevant data. Pull out your A, B, and C variables and the specific domain constraints. Third, select your analytical framework. This is where you determine the new period and the principal points of intersection. Fourth, execute with clear notation. Draw the axes, scale them accurately, and plot your critical coordinates. Finally, fifth, present with correct terminology. Do not skip any of these. If Alex just extracted the data instead of brain dumping, he'd get marks. If Sam took 10 seconds to deconstruct the command word before rushing, they'd get the marks. This sequence is your ultimate safety net. Once you've executed the analysis, your presentation of the information must follow strict conventions, particularly clear annotations on your graph. It is honestly shocking how many students lose marks simply because they drew a beautiful, geometrically perfect curve but completely forgot to label their axes. You need proper headings. You must use correct terminology. Your format must be appropriate. If the Cambridge question explicitly gives a domain in radians, like 0 to 2 pi, do not present your x-axis in degrees. And clear annotation is absolutely non-negotiable. Label the maximum turning point. Label the y-intercept. If it is a tangent graph, draw your asymptotes with a sharp, dashed line and explicitly label their equations. These presentation elements are easy, guaranteed marks. To lock this in under exam pressure, you need a memory hack. Try creating a quick mnemonic using the first letters of those methodological steps we just covered to recall the sequence perfectly. Deconstruct, extract, select, execute, present. DESEP. You could use something like draw every single exact point to remind yourself of the DESEP framework. Write it at the top of your scratch paper the literal minute the exam begins. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @theexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Welcome to Act 4, the interactive workshop. For our 4th section, we're opening up the examiner's warning list to reveal the absolute biggest pitfalls you must avoid. We are going to run through 3 rapid-fire challenges right now to test your surgical precision. Get your mental timers ready. Challenge number 1, the data scan. I'm putting a 60-second visual timer in your head. Look at this complex table of examiner data. Extract the core trend. What is the crucial takeaway here? Time's up. The trend is that confusing cause and effect or forgetting your format checks will instantly drain your mark potential. Look at that first row. If you change the period variable b, but stretch the graph vertically instead of horizontally, you've confused cause and effect, resulting in an immediate loss of logical reasoning marks. Forget your format checks, like Sam drawing a jagged, ruler straight line instead of a smooth curve for a sine wave, and you get slapped with presentation convention penalties. You are just throwing points away. Challenge number 2. Find the flaw. I'm giving you a flawed sample paragraph based on a 0606 past paper. The graph of y equals 2 cos x plus 3 has a maximum of 5 and a minimum of -1. The period is 360 degrees. Did you catch the flaw? To dodge those mistakes, you have to apply the deconstruct, solve, evaluate method. Let's look at that 4th bullet point. Check for reasonableness. If you are graphing 2 cos x plus 3, your maximum is 3 plus 2, which is 5, correct? But your minimum should be 3 minus 2, which is +1. The flawed sentence said -1. If you look at your finished graph and the curve dips below the x-axis, it's mathematically unreasonable. You immediately know you've made an error and you can fix it before the examiner ever picks up their red pen. Challenge number 3, speed writing. You have 30 seconds to write one perfect Peel paragraph comparing y equals sine x and y equals sine 2x. Go. If you are asked to evaluate alternatives or compare approaches like this, you must use a comparative toolkit. You need to identify both similarities and differences, supported by evidence. Your perfect paragraph should sound like this. Both graphs share an amplitude of 1, similarity/point. However, they have a critical difference in their period, difference. The second graph completes a full cycle in 180 degrees, which is exactly half the 360-degree period of the original curve. Evidence and explanation. When you write like that, you leave the examiner absolutely zero room to deduct marks.
We are now in Act 5, bringing it all together into the final system. This quote is the ultimate takeaway of our entire explainer. The method mark strategy guarantees that a clear process is rewarded, even if your final calculation slips up. Let me repeat that. Even if your final answer is wrong, method marks can save you. If you miscalculate a single coordinate under pressure, but the examiner can clearly see your Peel framework, that you successfully extracted the correct amplitude, successfully calculated the period, and mapped out the translation vector, they will award you method marks. This ties into our 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix, allocating time to show you're working. If you just sketch a totally wrong graph with 0 working out, you get 0 marks. Show the surgical steps of your operation.
Next time you face a complex trig graph, ask yourself, are you demonstrating the clear, structured methodology that Cambridge examiners are desperately looking for? Are you acting like Sam, just guessing the shape and rushing to the end? Or are you applying the core principles, deconstructing the problem step by step, checking for mathematical reasonableness, and claiming every single method mark available to you? The choice is entirely yours. Keep practicing, stay structured, and remember that you have the precision tools to master this. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.